Hello, good morning, welcome back. So in this video, I'm going to show you how to solve radical equations. So I list out 4 steps. So the first step is we want to isolate the radical term. So basically either the term with the square root or the cube root. Okay, so you want to isolate the radical, which can be the square root or the cube root. And for the square root, we do have a number. There is a 2 on the top left corner. But in algebra, we don't write the square, the 2, by the top left corner of the radical. But assume that there is always a 2 there, but you don't write it out. Okay, so now step 2. You're going to raise both sides of the equation to the power equal to the index of the radical. Again, the number that is located on the top left corner of the radical, we call that the index. Okay, so in order to undo the square root, you're going to square both sides. Okay, in order to undo the cube root, you're going to cube both sides. Why? So the radical can be cancelled or can be so you can undo the radical. Basically, remove the radical. Now, step 3, you're going to simplify and solve. And after simplifying and solve, step 4, we're going to check your solution to identify if you have any extraneous solutions. Why? Because since raising each side of an equation to an even power, so when you square both sides of the equation, you may end up with you may introduce extraneous solution that does not make the equation true. Okay, solution that does not belong. So that's why it's always good to check our solutions. So now the first example is going to be, so you have the square root of x plus 6. So there's the only term inside the square root, what we call the radicand. The radicand is the expression x plus 6. The negative x is away, the minus x is away from the square root. It's not inside the square root, okay, it's away. Then equal to 4. Because you can see the line stop at the 6. The line stopped at 6. The line of the radical is not coming over to the negative x. So be careful here, okay? So how would you do that? Again, you're going to follow step 1. You want to isolate the term with the radical. So let me rewrite the equation below. So the term with the radical is the expression square root of x plus 6. So we want to isolate this, the square root of x plus 6. So what will you do here? Okay, so we want this term to be all alone on the left side. So you're going to add x on both sides. Then you end up with square root of x plus 6 is equal to, this cancel out to 0, equal to x plus 4. Now we isolated the square root as we desired, as step 1, as you follow step 1, requested. So now step 2, you're going to raise both sides of the equation to the power equal to the index of the radical. Now here we have the square root because there's a 2 located on the top left corner of the radical. Okay, now to undo the square root so you can get to the x, the only operation that can undo the square root is if you square both sides. So that's what you're going to do. So we are going to square now both sides, y, so that we can get rid of the square root. The only operation that undo the square root is to square. Okay, so we square both sides. So now what happened? So you notice now the square root and the square are going to cancel each other out. Okay, they cancel each other out. So we are left with the expression x plus 6 is equal to x plus 4 squared, means x plus 4 times x plus 4. Alert, 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 alert. Do not think that, okay, you have x plus 4, so it's simplified to x squared plus 4 squared. It's not true. You're missing the middle term. So always use the knowledge of exponent Exponent of 2 tells us that you need to repeat the base twice. The base should be multiplied by itself 2 times. Okay, so that's why we're doing that. Then you're going to either use the box method or the distributive property to multiply. So for me, on the side, I'm going to use the box method. Okay, you're going to multiply using the box method. So you have x times 4, x plus 4 times x plus 4. So let's multiply. So x times x is x squared. 4 times x times 4 is 4x. 4 times x is again 4x. 4 times 4 is 16. So the only term you can combine as the middle term, 4x and 4x. So you end up with x squared plus 4x plus 4x plus 16, and 4x plus 4x add up to 8x. Okay, so now what you want to do next, we are going to, so you have a quadratic equation, okay? So that you need to write in standard form. So standard form means one side needs to be equal to 0, okay? Since I have the x squared on the right, on the left, on the right side, I'm going to leave this expression on the right. So I'm going to move this expression, x plus 6. Okay, so to undo x, positive x, I'm going to minus x. And to undo positive 6, I'm going to minus 6. And what if I do on one side, I do on the other? So minus x. So make sure you line up correctly to its like term. So like this. So the new equation is going to be equal to, and then 8x minus 7 is going to be plus 7x. And 16 minus 6 is plus 10. So I want my equation to be the variable to be on the, I want the 0 to be on the right side. So that's why we wrote it on the right side. Okay, if you want, you can solve it like this. Okay, so now because the coefficient of x squared is 1, so we're going to do the easy way, so I'm going to write 2 empty factor like that. So since the coefficient of x squared is 1, so I can only write x, I'm going to write x in each factor. Okay, why x times x is x squared. So the only reason I'm doing this is because the coefficient of x squared is 1. So now I'm going to start with the product, 10. So can you think of two numbers that multiply to 10 and add up to 7? Can you think of a factor of 10 that add up to 7? So the factor of 10 that add up to 7, I'm thinking it's going to be 2 and 5, right? 2 times 5 is 10, and 2 plus 5 is 7. So I'm going to replace, so I'm going to write here x plus 2 and then x plus 5 right here. Then you're going to apply the zero product property. You end up with x plus 2 equal to 0, and then x plus 5 equal to 0, and you solve for x. Here, for x to be alone, you minus 2. So the final equation is going to be x equal negative 2, and the second one is going to be x equal negative 5. So you have our two solutions. Then you're going to, okay, so let's go back. So remember, we square both sides to cancel, we square both sides in order to cancel the square root, okay? Then we simplify and solve, okay? So what happened here? So when you square both sides, the expression x plus 4 squares simplify to x squared plus 8x plus 16. Then you wrote the equation in standard form by doing what? By subtracting x and 6 on both sides. And then you have the quadratic equation written in standard form. And the quadratic equation is factorable. Okay, so you're able to solve the quadratic equation by factoring. Okay, so now we have two solutions, and you're going to follow step 4 which is to check our solution to identify any extraneous solutions. So let's do that. So okay. So let's check our solution on the far right. So let's check. So to check our solutions, I'm going to start with the solution x equal -2. Okay, so x equal -2. So I'm going to start with the original equation. What we start the original equation. And now whether there used to be x, I'm going to plug in -2. Okay, -2 plus 6 add up to 4. The opposite of -2, the opposite of -2 is +2. Okay, so now I know that the square root of 4 is going to be +2 plus 2 add up. Is it going to be equal to 4? Yes. 2 plus 2 add up to 4, and 4 is equal to itself. So this is true. So I know that x equal -2 is actually a solution to this radical equation. Now let's move on to the next one. We're going to check x equal to -5. So you want to see both sides are the same. So plug in -5 and let's find out. Okay, square root of -5 plus 6 add up to 1. Okay, now the opposite of -5 is +5. Now the square root of 1 is 1, because 1 times 1 is 1. The number by multiply by itself and you get 1 is 1. Is it going to be equal to 4? If you ask that, okay, let's find out. 1 plus 5, as you can tell, is, as you know, is 6. And 6 can never be equal to 4. So it's never true. Okay, so the equation is never true. So we identify here the extraneous solutions, which is x equal -5. So that's what I'm going to write below that x equal, okay, so x equal -5 is the extraneous solution, because it doesn't make the equation true. It's the extraneous solution. So the only solution to this radical equation is what? Is x equal to -2. Okay. So again, so what happened here? So remember, if you go step by step, we isolate the term with the radical first by adding x on both sides. After we isolate the radical, to undo the radical, since the radical is a square root, you have to square both sides, okay? So after squaring both sides, we notice here that x plus 4, the quantity everything squared simplified to x squared plus 8x plus 16. Alert, alert, alert. It cannot be x squared plus 16, okay? And I explain why, okay? So, because x plus 4 squared means that the factor, the base needs to be multiplied by itself twice because the exponent is 2. So we now wrote the quadratic equation in standard form by doing what? Because standard form means the one side needs to be equal to 0. So I chose to make the left side to be equal to 0. So to undo plus x and minus x, to undo plus 6 and minus 6. And whatever you do on the left, you have to do on the right. Now you have the quadratic equation written in standard form, okay? And you go from the highest exponent to the lowest exponent of the variable x. Then it was factorable, and you factor it to be x plus 2 times the factor x plus 5, and you apply the zero product property, and you solve for x. So now the final step was to check the solution. All you have to do to check the solution again is to do what? Okay, we take the solutions and you plug it into the original equation. So whether we use to have the x, you're going to plug in -2, and check if both sides are going to be the same. So for x equal -2, both sides matches. It's true, 4 is equal to itself. But for x equal -5, you notice that both sides are not the same number. Okay, so it's not true. So the equation cannot be, the solution cannot be x equal -5. And we conclude that x equal -5 is the extraneous solution. So the only solution to this radical equation is x equal -2. Okay. So this is an example for number 1. So let's do number 2 for you to practice. This time you're going to use a cube root. Okay. So for number 2, you have the cube root of 2x plus 1 minus 3 equal to 0. So again, it's the same thinking as before. Follow the steps that I hope you took note. Follow the steps from 1 to 4. Okay. And I would like you to pose, but this time around, you're not going to square because we don't have it. It's not the square root, it's the cube root. You're going to cube both sides. So please pause the video and solve this cube root equation. Okay. See you soon. Okay, so I solved this already. So I hope you end up with the same answer. Okay, last step 1, we isolate the term with the cube root. So for this, you have to add 3 on both sides. Then to undo the cube root, we cube both sides. Okay, this time around to undo the cube root. Okay, so then now you have the cube root is gone. So now next, so remember 3 cubed is 3 times 3 times 3, which is 27. It's not 9. Okay, then you minus 1 on both sides, and then you divide by 2 to get x alone. And you get x equal 13, and you check, oh, so x equal 13, and we check our solutions. But whether there used to be x, so you take always take the original equation, and whether it used to be x, you want to plug in 13, and we compute, and you end up with 3 take away 3, which is 0, and 0 is equal to itself. So it's true. So the only solution to this radical equation is x equal 13. Okay, so I hope this video was beneficial to you and you learned a lot. So if you learned a lot, please please give me a like, please like the video, and I hope to see you into the next one. Have a wonderful day and see you next time. Bye-bye.